Okay. Sorry about that. Again, my name's Angus. I'm with Sellen Construction in Seattle, and I apologize straight off the bat because I'm going to be spending a lot of time talking about Seattle. I know I'm in Portland today, but Sellen does a lot of work in Seattle, not so much in Portland, but a lot of the themes I'm going to be talking about today are going to be, I think you're going to find are translatable between here and pretty much any location. My own personal journey with cross-laminated timber started about 5 years ago when I was working on the Bill and Melinda Gates Foundation project with a very, very amazing structural engineer named Hans-Erik Blomgren. Some of you may have heard him speak yesterday afternoon. He talked a lot about cross-laminated timber, extremely bright, and also had a lot of forethought. He came to me one day and asked if I could help him try to find a way to look at CLT in construction projects that we were working on, and also specifically about the feasibility of those systems in everyday work that we were looking at. So it sounded like a significant challenge. We started talking to several people that we knew in the industry and asked them if they just kind of, as a pro bono, non-billable type exercise, which is always popular with your boss, by the way, to look at some of these systems and figure out if there was a way for that to work in Seattle and elsewhere. We obviously had examples of it from around the world, but just really hadn't gained traction in the U.S., and we had some partners and neighbors to the north of the border there that offers a few opportunities to go check out some things, but for the most part, when we first started, there really wasn't any benchmark. So understanding what some of those drivers were, what the supply chain was like, and what some of the competency that was going to have to be established before we could use it was pretty significant. It was an exciting prospect. So just really quick, I just wanted to kind of give you a quick overview of what I was going to talk about today, which was really, why not high-rise wood, which really was the crux of the question that Hans-Erik had asked. And when we say high-rise wood, predominantly we're talking about cross-laminated timber's ability to facilitate high-rise wood. Obviously, we've had engineered wood products that have helped facilitate larger wood structures. But for the most part, when we're talking about dimensional stick frame, we're talking about projects that terminate at 5/2, right? 75 feet, somewhere in that range. The opportunities that are being afforded now with wood, or the high-rise wood, through the use of CLT is the part that's really is interesting and obviously anew for all intents and purposes. Why haven't we seen it yet in the marketplace? There's some things that we've looked at, again, over the past 5 years. I'll share with you guys some example studies that we've done. And you guys have seen it, some projects in North America, predominantly in Canada. There's a few being built here in the States here that are starting to gain traction, but they're still kind of in the demonstration project phase. They really haven't gained traction in the broader market, and talk about some of the lessons learned we've had from some of those example studies. I want to give you guys some marketplace context, because ultimately I think at the end of the day, if this really is going to be used as an everyday material, it has to pay for itself. And I just want to give you guys sort of a sense, maybe this will be reminders for you, but just a sense as to what are the economics behind this? What's the revenue versus the cost associated with developing projects, and how does CLT potentially fit into that? I'm going to, again, look at 3 different example studies, and at the end of it wrap up with just sort of a, what is the catalyst? What's going to be what's going to take CLT and move it into that everyday material instead of the demonstration project? So why not high-rise wood? Most of these same arguments we all know very well, right? It's very light, it's very strong, it's very versatile. The environmental story is fantastic, both from the standpoint of just embedded carbon and the renewable resource, but also just the fact that I have friends in Eastern Washington that have watched acres and acres and acres of wood just go up in smoke, literally, over the past 2 summers. My dad was from BC, worked for the BC Forest Service. I was always brought up understanding the issues associated with forest management, and just watching all this wonderful thing, all these wonderful resources that we have just again go up in smoke just seems like a terrible waste. Outside of just the embedded carbon issue. Design flexibility, there's just a ton of options that CLT affords that some of the other traditional materials didn't immediately afford. Some of the things that concrete does well, steel doesn't do very well. Some of the things steel does very well, concrete doesn't do it very well, but CLT kind of bridged the gap between several of their best characteristics, which was intriguing. Rapid assembly, we're going to talk a little bit more about what's driving rapid assembly, but there is definitely that possibility for building these projects in more or less the same way that we would build projects out of precast concrete. or it may be steel, but for the most part, it's very akin to that, especially if you've done precast concrete beams, columns, and plank projects in the past. They're very similar to that. So that there's an opportunity here for these projects to go up extremely fast, as we've heard some of the other panelists describe, and you've probably seen yourself. And then also the cost competitiveness issue. You know, it offers an opportunity here to be cost competitive with concrete and steel, and again, the mid-rise and high-rise construction, but we'll talk a little bit about some of those parameters that can test that particular opportunity. So then, why not here? So the first thing we started to notice when we were, you know, as a group looking at this, you know, what were the drivers and what were the potential impediments to being used widely was really it proved to be pretty cost prohibitive in early stages if we looked at it as sort of a like-for-like replacement with concrete and steel. It really didn't prove to do the same types of things as concrete or steel could do, but ultimately we just had to kind of change parts of it to basically make it a little bit of an apples and oranges comparison, but for the most part we could still pretty much get there with the same characteristics as those two traditional materials. This is going to be a slightly different application of them. Trade level and experience, I mean, as Mr. Tobin just illustrated there, you know, I heard the same thing, actually, had the good fortune to speak with Bird Construction, who did the Earth Sciences building up at UBC. One of the first things we did as part of our early studies was to go talk to some people that had done these projects in the past. And a gentleman up there named Don Weicker was actually a great resource from that, and learned a lot from them as to, you know, what their initial studies were, their initial Earth Sciences project, moving on to a couple other projects in the future, and just watching how their productivity had changed and the lessons learned associated with it. And it was pretty exponential, but it is an issue, really, at the end of the day. I mean, it's an unknown quantity, and most of our field crews, for the most part, whether it's carpenters, iron workers, whatever else, they're used to what they're used to, right? It's learning a new trade, new skill set, so it is an issue moving forward. Acoustics, you've heard about that. Fire code, structural code, you know, you've heard all these potential issues and how they're being addressed, in many ways overcome at this point. 5 years ago, that wasn't the case in many ways. So some of these elements are really starting to gain traction and being figured out, somewhat dependent upon exactly what jurisdiction you're in. But again, there is some progress on those fronts. And then market perception. That was the one thing that I was most interested in, was trying to understand, once we got done with some example studies and made some presentations to some folks, specifically developers and owners, what were their concerns? Because really we were going to learn kind of what was going to keep the money, for all intents and purposes, from funding these projects, what was going to be their concerns moving forward. And we heard everything from insurance issues. I mean, there, you know, a lot of insurance companies had never dealt with this before, so they didn't really understand what it was and how durable it was, or, you know, what the fire issues associated with it were. And even just sometimes the saleability and the durability of the product. They heard wood and they thought stick frame. They thought it was a 25, 30-year, you know, project as opposed to a 50, 70-year project like you would have potentially with concrete and steel. A lot of it, again, was just perceptions, but they were important to understand, especially as we move forward and try to gain better traction with it. So as part of that marketplace perception, I just want to give you guys kind of a sense for maybe some of the obstacles in front of all of us as we're trying to implement more CLT. But there's really three different things that you'll notice. One is time. Time in the marketplace is very key. If we look at just this slide, this is just residential context within Seattle, high-rise, high-end multifamily projects. These blue bars here basically are just the perceived stabilized rental rates at which people are basically performing high-end high-rise residential projects, and then what their construction cost is in relationship. And you can kind of see that they're moving in concert, right? As you have higher rental rates, the construction costs are going up. That can be due to escalation in the marketplace, but it also can be just the product is getting better. I liken it to an arms race within Seattle right now as far as multifamily is concerned. They're all trying to one-up each other. And as you've seen, I mean, a project in the 1970s is different from a project today, right? The code compliance issues are different. The expectation level for the bells and whistles are different. So it's sort of a moving target here, right? And that's one of the challenges, is that ultimately it's moving in a certain direction, but it's also moving in concert with the marketplace. So time is important. The other one considers location. Now, as I said before, this is where I get Seattle specific. So if you know these neighborhoods, congratulations. If you don't, just know that the top one is downtown. The kind of middle, lower ones are sort of residential neighborhoods outside of downtown. but they're all Class A office space. This comes from Colliers, by the way. This is actually what they project, and this is what they've noticed as far as Class A office rent per square foot in different neighborhoods. And that's literally at just the city level. Now, if we looked at national or regional differences, you'll see some really stark examples. One of the starkest, actually, and something we deal with quite a bit, I know you guys do as well in Portland, is it's the issue of what you can charge for rent, both on the office side and residential side, in New York versus Seattle, or in LA versus Portland. There's a stark difference between the two. Hard costs also don't move in concert in direct proportion to that either. So there are many projects like in New York where you'll see tall, slender towers that are really cool, right? They're charging 2.5 times X what we can charge in Seattle in many cases. But the construction cost can be only 1.8 to 2 times X. That differential affords all sorts of opportunities for a design license. So I want you guys to kind of remember that, because that's one of the things that you'll notice is that in many cases, even if we're looking at the city level, the downtown area for us justifies all sorts of construction costs because they can charge more typically per square foot than other neighborhoods even maybe a few miles away. So that's something else that is obviously key to understanding what is going to be the opportunity moving forward. And obviously the building configuration. So is it tall and slender? Is it, you know, short and fat? Those all have massive difference or massive effects basically on the overall construction cost, which can justify cost overruns on certain parts or pieces of buildings. So for the opportunities here for CLT, I want you guys to remember the high-rise 85-160 there, that second bar, and the differential between that and the one immediately below it. Just know that's a pretty significant gulf. The moment you test that limit of 85 feet, the 5/2 realm for residential, or if you're looking at office, you're going from, you know, maybe concrete PT decks to a steel frame building that's a taller building at that point. There's a lot of infrastructure costs, there's a lot of code requirements, the structural systems tend to sometimes get more expensive, and one of the biggest ones is that code and land use zoning basically most of the time reflect the fact that you have to make the building more slender as it goes up, right? Most land use code doesn't allow big battleship buildings that are, you know, 30,000 square foot floor plates that are 500 feet tall. Not anymore anyway, right? It's always the New York wedding cake type scenario that as you go taller, you get more slender. That's how some of these things manifest itself. So we're thinking about the differential between mid-rise and high-rise from 85 to 160 or higher, which we've heard before is kind of like that potential sweet spot for CLT. It's also competing against projects that are the stick frame projects that from a rental rate differentiation standpoint really aren't all that different. I'll give you an example. So in Seattle, there's a Sunset Electric apartment building that is a 5/2. They're currently getting $3.50 square foot rents for those apartments. We're building 40-story projects that cost upwards of 80% more than they do, if not 70%, somewhere in that range, and we're only getting $3.70. So that differential is huge. It's a much better building. It'll last a lot longer, but the reality is that, and it's much more important piece of property, but the reality is that those two different products have to compete against each other in the marketplace. And that happens as well in the lower elevations as well, not just the high rise. So if we were just to extrapolate and kind of pull out one of these examples, the core and shell office building. Core and shell office buildings, predominantly those first 3 bars are predominantly the structure. That's usually the biggest part of a core and shell office building. The 4th bar there is the exterior closure. That's the part that yo-yos quite a bit, depending upon what size and configuration of building you have and height. And then roofing, interiors, conveying, mechanical, electrical. GCs is that bar that's kind of the 5th one over from the right. That one is basically a function of time. So when we're thinking about CLT and the speed of construction, that's the one that can be best affected by that. Because for all intents and purposes, those are indirect costs. They're not really being put into the building. They're just helping to facilitate the building. It's paying for guys like Mr. Tobin and well, actually, you worked. It's paying for the project managers and whatnot, the office staff and whatnot that are helping to facilitate the work. Not so much the costs associated with paying people to actually put work in place. So really, it is kind of an indirect cost to the owner, but that's another opportunity there. So when we look at CLT in relationship, there's a potential here that there's a cost premium with the structure, or the superstructure in particular, but it's being offset potentially by foundation savings, by interior savings, maybe mechanical, And almost obviously the most is the GC potential savings. So if we're looking at really where the opportunities lie on office shell and core, it's really kind of in the GC savings to help offset. But at the same time, when you look at the size of these bars, even if you were to cut that in half, which you're never going to do, it's going to be very difficult to help pay for that premium associated with the superstructure, potentially. So we'll get to why that isn't necessarily the case all the time. That potential cost premium was when we first started looking at CLT, and again, when we were looking at it part for part. When we started to get a little bit smarter about that, that red bar got smaller and smaller. So the first time we ever looked at this, we looked at it with, again, Hans-Erik Blomgren, and a firm across the street from our office, Thompson, who is probably one of the more prolific multifamily architects in Seattle. They do a lot. They have a high-rise and a low-rise studio. Worked with them predominantly because I could kind of sense that the competition was really going to come from the 5/2 realm, and making sure that if there was an opportunity there to use CLT, that we're testing it against that marketplace. And they actually proved to be a great partner in that realm, and offered a lot of suggestions on how to maximize opportunities there. What we really were concerned with, though, is upzoning. So Seattle, in particular, I know they're doing this in Portland as well, but there are massive swaths, predominantly along the transit-oriented development corridors, where there's upzoning now from 65 to 85-foot height limits to 160 to 240-foot height limits. It offers all sorts of opportunities for density that we never had before. Now remember that 85 feet, that's a 5/2 for all intents and purposes, right? It's usually about 75 feet in reality, but you're not going to usually build that extra story. You might sometimes out of sheet metal stud framing or something like that to get the nice story. But for the most part, generally speaking, you're not going to do most buildings 10 or 11 stories out of concrete because they're not cost competitive when you have a 5/2 on the same site. So if you're looking at the opportunity to go to 125, 160, 240, that metric starts to change for you. And it basically means that if there's a cost premium associated with the structures, you can start to amortize that over more and more square footage, which is where, again, CLT offered a great opportunity, which is why we were excited about it. We looked at two different options. We looked at an office component and a residential component and tried to test them against, again, the traditional methods, concrete and steel. And what was interesting about it was that at first blush, it was not cost competitive to dimensional wood framing at all. It was cost competitive to concrete and steel once we got smart about how we used it. The opportunities to take wood structures taller was huge. It meant that people that have properties that may have been worth $2 or $3 million based upon a pro forma that was justifying a 5/2 might make their property worth $5.5 to $6 million, because now they could take it to 160 feet or taller. So there's a huge opportunity there for both property owners and developers. There were marginal schedule benefits insofar as we were using it as replacing parts and pieces. If we used all CLT panels, both vertical panels and floor panels with engineered wood beams and columns, there was huge benefits. But if we were doing it like kind of interdispersed, especially in the residential example, it was difficult to really accrue a lot of the schedule benefits that we were hoping to get out of it. It was interesting as well, in concurrence, unknowingly, in concurrence, Malum Architects, DCI, and Walsh Construction in Seattle were doing a very similar exercise to us. And they presented a couple of years ago, I think, on their student housing project at University of Washington, sort of a mock example. And they found almost the exact same, it was heartening, they found the exact same conclusions. It was a little bit more expensive, the schedule benefits weren't as good, and really what you needed to do was implement all wood, all mass timber to really get those schedule benefits. The fire life safety issues had to be addressed because at the time we really didn't know what what the trend was. Hats off to people like Joe Mayo and Hans-Erik in Seattle that have really led the charge from the city of Seattle standpoint, and really getting them to sign off or at least express interest in those projects. But at that time, it really wasn't addressed. The possibility of unique user experiences was huge. So in the same way that we exposed concrete in some projects, we had the opportunity to do wood as well. But ultimately, the rental rate couldn't support the hard cost premium. So that was what was kind of tricky about that. So we looked at it a different way. We said, okay, what if we modularized the entire structure on the same site? We built modules just the way that, in many ways, the same way that dimensional wood framing people have done that, with hotel projects in far-off places. It was an interesting exercise. Really, the idea was just basically, again, to try and accrue as much of the schedule savings as possible. The nice thing about CLT is that it's incredibly rigid and stiff, and it offered the opportunity to do double duty, especially in transport and then also lifting into place. So it offered a lot of different opportunities there. Ultimately, though, we'll just see a couple variations of this. We tried to look at different variations of the panels and modules. I looked at Hammerhead Style, which was basically 2 units on one side with a corridor in the middle. We looked at this style up here right now that you're seeing. Issues there revolved around acoustics in between the units, which is kind of an ongoing issue with CLT and residential experiences. But we tried to, again, try to keep the structure as much CLT as possible to try and accrue those benefits, because that really was where the schedule benefits lied. And then ultimately, looking at just one unit, we looked at ganging units in between as well, with openings in between to try and, as close as possible, replicate what apartment units are like. Hotel, student housing, and I mean, if you're going to do it, prisons, are for the most part the same kind of modules, right? They're relatively small. Apartment units are tough, though, because they want to be basically at least 2x, in many cases, the size of what you would have for a hotel guest suite. So that was another kind of lesson learned coming out of that. The lessons learned coming out of this was obviously the speed of construction was huge. Over the course of a 14-month project in traditional 5/2 framing, we could do 9, 10, 11 stories. Actually, we got to 12 stories and still be at about 11 months in total duration. So it shaved basically 3 months off the schedule, but we were putting in place 3 or 4 more stories. The issue with the schedule savings, too, to keep in mind is that you're only as fast as your slowest trade, for all intents and purposes. If you still have to do something in the corridors, or there's some other lagging indicator in there that's holding up the entire project, a lot of the schedule benefits associated with CLT are kind of negated. So it's something, again, to try and keep in mind when we're looking at opportunities to use CLT. There were limitations to the module design, just like any other prefab module construction. The exterior envelope presented some constraints, nothing too huge, but there were some opportunities. There was limited CLT panel replacement, especially when we're looking at ganging the units together. And then it was kind of lumping in one more unknown on top of CLT. So most of the people we talked to said, okay, very interesting as an academic exercise, but for the most part, I don't know CLT, and I also don't know I've never seen a modularized project before, but at least at first blush, it looked like it was possible. So that was kind of encouraging. Last year, we teamed with Miller Hull, Washington State University, and Arup again. Brian Court and Craig Curtis with Miller Hull, and Todd Bayreuther with Washington State. Washington State was proposing on the USDA tall wood competition. They had a couple sites in Spokane that they were looking to develop, and these were the 2 potential options. One was on the left there, it was a student housing project. Again, kind of that mid-rise construction, 9 or 11, 12 stories. And then off to the right was the office version of that, next door. So we looked at trying to replicate some of the same constraints associated with office. The thing that was interesting about the office span, so most of the people here that have worked on offices in the past, you'll know that there's always, as far as Class A is concerned, a 40-foot span that's desired between core and outside columns. We had a really hard time achieving that. That was one of the constraints, that you got the glue lamp beams to a point where they were so thick that they were starting to erode the interior experience. We built the columns inboard to try and do that, and cantilevered off the CLT panels to try and make up for that difference. But it was a difference between that and traditional concrete and steel. The benefit, though, was ultimately that you could expose the ceilings, which was great, right? It's a beautiful look. It offers huge savings on the interior improvements for the tenant improvement cost. But that's also one of the issues, especially if we're looking at developer-led core and shell office projects, is that benefit really accrues to the tenant. And most of the people we've talked to on the development side have always said, well, that's interesting, I like that, but that doesn't help me, that helps the tenant. So a lot of the build-to-spec people would appreciate this, but the core shell developer office, or office shell and core people, it's an argument that doesn't have as much resonance with them. So that was kind of something that's sort of disappointing, but it was a reality. Student housing had pretty significant premiums associated with it, especially when we look at how cheap student housing can be. A tough market for it to kind of compete against. From the office side, it was basically, the drive here was to make sure we had efficient floor plates as much as possible. Not traditional office spans again, and the office TI was the biggest benefactor. But at the end of the day, the beauty of that project was going to be very much akin to what the bullet foundation project is in Seattle. And if you've ever talked to anybody that has worked in that space, they love it. It's kind of one of those things that's hard to put a price on, but I think most developers now are starting to understand that there is a benefit to it overall. So what is the catalyst? Coming out of all these studies, I think likely it remains an upmarket building material. I'd like to see it, on the development side, if it had an opportunity in San Francisco, New York, where there's these premiums associated rental rate that could potentially afford the building material as long as the prices kind of remain where they are today. But they're coming down, so it's becoming one of these. And as the understanding of the product gets better, it's going to offer more opportunities for it to get to the second tier and third tier cities. But it's going to be a challenge moving forward. Bigger, taller is better. So the more of the CLT you have, and the taller it gets, that schedule benefit just gets exponentially better. So looking at it from the standpoint of a future development, if somebody could really bite the bullet and do a tower, you'd really start to see most of the benefits accrue. The all-wood solution is key to faster delivery. I've seen some projects that have looked at concrete cores with wood framing, which actually is difficult because really at the end of the day, you're not really changing the metrics at all. You're basically as fast as steel construction at that point. If the concrete core is your critical path, then you're not really changing the overall construction schedule. What would really change the overall would be, again, CLT panels in the core, CLT panels in the floor, and wood or engineered wood beams and columns. The charring versus fireproofing, you guys have heard of that before, but it's a hard cost versus schedule benefit. The issue there is that as you get bigger than you need to be from a structural standpoint, it's potentially a hard cost premium, but it's definitely subsumed by the schedule savings. Steady demonstrated demand will likely reduce cost, hopefully on the supply side. And then core shell premiums versus tenant savings, obviously something to be kind of looked at in the future, and convincing developer-led core and shell office projects that there is a benefit to them on the TI allowances they typically carry in their budget is going to be key. Lateral and diaphragm issues are still a challenge for high seismic zones. I've talked to some people on the East Coast that have dealt with some of these issues in the past that we don't have to deal with the continuation of the concrete topping slab or anything of these natures that basically is sort of a penalty to the project. Ultimately, it's something they're going to look at in the future as well. That's going to be difficult to circumvent. But ultimately, I think that we'll find ways to continue those diaphragms and make it possible for us to implement them in even high seismic zones. This is kind of my wish list for the future, and how we could actually implement CLT on more projects. And as we've gone through these exercises, it seems like it's really the path forward, which is really hopefully maybe the two of these first columns, the idea here, the number of projects in the y-axis, the time in the x-axis, but ultimately a concert of public subsidies and public incentivizing would help to make CLT a more viable option. Public incentivizing, that could even come in the form of different land use code allowances, which we've had discussions with City of Seattle in particular about that. So if you can maximize FAR in a different way than maybe your neighbor next door, then that gives you a competitive advantage over your competition. And ultimately, hopefully that leads to more public large entity support. We've had discussions with some of the major developers that are interested, but they want to see a project that they can actually look at, step on, and see go up in place. That's kind of what they're waiting for. So the demonstration projects are going to remain to be important catalysts for future development. Ultimately, I'm hoping when that happens that the private side, the wider acceptance will become more implementing this materials in everyday products. So that's, I'm hoping, is the ultimate goal. So apologize, a lot to get through, but that's all I have. Thank you.